Hello everyone. In this video, we will be discussing the topic dimension reduction. Dimensions, high dimensionality in data science refers to the large numbers of predictors in the data set. Uh, why do we need to reduce the dimensions? Uh, it can lead to multicollinearity, double counting, curves of dimensionality, and many more problems. So we need how will we identify multicollinearity in Python? When large databases have many predictors, it is unlikely that all of these predictors are uncorrelated. Multicollinearity, which occurs when there is substantial correlation among the predictors, which can lead to unstable regression models. So let's see how we will be identifying multicollinearity. This will be we will be importing these packages pandas statmodels.api, statmodels.stats.outliers underscore influence, and we will be using serial database. And once we have imported the modules, we will be pulling three predictor variables and put them in their own data frame called the data frame X. This is what we have done. Now that we have predictor variables all together, we will be using scatter matrix command with X as input to create a scatter plot matrix. This is the command we will be using to create a scatter plot matrix. Let's execute the code. Yeah. So this is the code. We have imported the packages, and this is where our data set lies. This is we have created a predictor variable, three predictor variables, and stored in a data frame X, and created the scatter plot. Ignore the further code. We will be commenting out this. I will be using multi-line comments here, which is done in this way. Let's execute this code. So this is what we got our scatter plot for the predictor variable sugars, fiber, and potash. Further moving on, the result of the scatter matrix command is shown. This is our scatter matrix result. Notice here that the command creates both scatter plots and the histograms. These are the scatter plots and this is the histogram. To obtain the VIF values, we need to do a little data cleaning. So let's do that. We have used the dropna command on the X dataset. This is what we have done. Let's uncomment this section. And also I have used the add constant on the our data frame X. Dropna command on the X data frame to remove any records with the missing values. This removes the record with missing values, and then make sure you add the constant term X to the data frame. Finally, we will be running the variance underscore inflation underscore factor, which is what VIF value we need to calculate that. So this is the syntax for obtaining that. The output will include a VIF value for the constant term we added. So we have to ignore that. The VIF values of interest are the three predictor variables, which are second, third, and fourth numbers output by the variance inflation factor command. Let's execute the remaining section of the code. So these are the VIF values which we have obtained. That is variance inflation factor. This is our scatter plot, and this is our scatter plot, and these are the VIF values obtained. Yes. The next question, that is the next statement states that how will you apply principal component analysis using Python. So we need to load the following packages to apply the principal component analysis, that is pandas, numpy, scikit. From that we will be importing standard scalar and sklearn the decomposition import PCA. This is principal component analysis. So what is principal component analysis? It seeks to account for the correlation structure of a set of predictor variables using smaller set of uncorrelated linear combinations of these variables called components. So this is what principal component analysis does. This we need to import these packages. Then we will be reading two dataset, clothing underscore store underscore PCA underscore training, and the another one. This is the code for that. Let's execute the code. I have written the code already. This I have imported the packages. This I have accessed or loaded the dataset in the following variables, respective variables. Next is we will be separate the predictor variable from the rest of the training dataset using the drop command. As we only need the predictor variables. Note that we drop the target variables sales per visit, so we are left with only predictor variables. This approach is best suited for when the target variable and predictor variable of interest are the only variables in your data. So this is, we have dropped the sales per visit column, and then we have printed the correlation matrix of the x variable using the x.cor command. Let's execute this portion. Let me comment out it using the multi-line comment again. Just a second. So these are all the predictor variables we got. This is the correlation matrix for X. Moving on to applying PCA. This is principal component analysis. Now we will run PCA with 5 components. First, we will specify the number of components using n underscore components in PCA command. Then fit the PCA to the data set, to the data using fit underscore transfer with X as input. So this is the code. Once PCA is run, our next task is to look at the amount of variability explained by each component and the corresponding cumulative variability explained. Using the PCA 0, 1 object and explain variance ratio to obtain the variability explained by each component. This is the syntax of how we will be writing it. Then let's execute this portion of code. This is what it will be giving, explained variance ratio for each principal component. It is for the respective components. And then we will be calculating, evaluating the cumulative explained variance. Okay. Yes. It will be calculated using the CumSum numpys function. Let's execute this portion. Here we got the cumulative explained variance. Our result in this section are for original unrotated components as of this writing. Python's sklearn package does not have out-of-box command to perform var max rotation on the components. That's all for this video.